And hello, welcome everyone again. So, last time we left off over here where we just replaced the eta terms and whatever um, to get a theta prime, where it's del theta del eta. Okay, so that's the easy part. It deals with the x terms, right? It deals with the x terms. And of course, I can change this to x over L, and we can just deal with this part a bit later on. We'll just leave the term alone as it is, and let's now consider how we're going to change this del theta del y star. Okay, so just to prevent confusion first, before I start doing anything, I'd like to say that eta is, it's easier to see in terms of y and x as compared to y star for now, because now we have this new thermal boundary layer to take care of, because that's how we non-dimensionalize the whole thing. So how then do we deal with y? Okay, I'm going to combine back delta t into y star, so that I will just get y. Okay, delta t into y star will be y. Reason I'm doing it is so that it's easier. Okay, it's easier to do our differentiation bit. Okay, so I'm going to combine the delta t back, delta t squared, which is the thermal boundary layer. Alright, so delta t is going to be a thermal boundary layer. I'm going to combine it back into y star to become y. Okay, once it has become y, now I can just do very simply del by del y. Okay, fraction del by del y equals to fraction partial eta partial y. Okay, fraction partial by partial eta. Okay, not too bad there. So let's do the first bit. I want to find partial eta partial y. Okay, partial eta, not eat. Oh, hope you're not too hungry. Partial y. Okay, what will this be? Okay, so we look at this eta term. So it's everything else is constant with respect to y. So the thing is just fraction 1 over 2 square root of u infinity on top and nu x at the bottom. And the other way to think about it is just eta over y. Alright. Okay, so now let's consider the second derivative, okay? Because we're going to do partial square by partial square by partial y square, right? So we're going to change partial square by partial y square, and that's equals to partial by partial y. Okay, fraction partial, okay, partial y. Okay, and you'll have what are we differentiating? Partial by partial y. Okay, so we're going to have partial eta partial y. So nothing too new there. Nothing too new here. Okay, nothing too new here, right? So we can just substitute eta over y into this thing. Okay. Okay, I think I made a mistake there. It's partial by partial y, partial by partial y. So inside there should be a partial partial eta. Alright. So the whole thing is inside there. Yeah, this is the correct way. Okay, so what are we trying to differentiate? Oh, I mean, we might as well just put in theta in there so that it's clearer what we are trying to do. So partial theta, partial eta. So we're doing the second derivative term. So I'm doing the rightmost term, and we kind of consider the left term here. Okay, so what's next? We'll need to perform what is this? Product rule here. Okay, let's do a product rule here. Okay, so we have first we have this. Okay, let's just convert it to theta prime first. Convert this whole bit here to theta prime for ease. Okay. Okay. For RHS, yeah. Let's see how long I have. Okay, still 14 minutes. Ideally hit 20 minutes. All right. Now we do a what do you call that? We do a product rule on this. So let's do a product rule on this. So one side will be partial y partial theta prime. Okay. Theta prime partial y and partial eta partial y. And then we have the other way around. Okay, plus partial 2 partial squared of what? Eta, not e, partial y squared, and then we have theta prime. So now there are two things we need to figure out. Okay, this one is a bit easier to do. Okay, this one's a little bit easier to do because we can just do some change of variables there, and we'll see what happens. Okay, this guy here, let's see what we need to do about it. So let's do the right hand side term. So we have partial square eta partial y square. What will this be? You'd have a partial by partial y of what? Eta over y. Okay, because that's what partial eta partial y is. It's just eta over y. Right? But the thing is that if you see eta over y does not depend on y at all. Okay, partial y eta over y doesn't depend on y at all. Of course, you can do your own quotient rule and like convince yourself, but this whole thing is independent of y. U infinity, nu, and x are all independent of y. All right. So I can just as well say that this is 0. So partial square eta partial y squared. This whole thing is 0 because there's nothing to do with y at all. Okay, so I mean, you can do a quotient rule to convince yourself. You will have eta partial y minus y partial eta partial y. Okay, so yeah, if you do that, you will find that the numerator just cancels out. Okay, I kind of talked about that in my previous boundary layer boundary layer kind of thing, except it's using the dimensionless y, but the same dynamic applies. Just try the quotient rule and you will see that it will just reduce to 0 if this proof does not convince you. Okay, because all of this is constant with respect to y. So so it turns out that this side is pretty straightforward. Okay, one of the terms just disappears, and that's always good news. So let's copy and paste it all here. And I'll just delete off one of these terms, partial square eta partial y square. This will disappear. So let's make that thing disappear. Okay, yeah. We have no infinity stones here, but we don't need infinity stones to make it disappear. If you catch that reference. Okay. Yeah. Let's see. All right. So let's carry on. I mean, this bit you can just replace by partial eta partial y, and so let's replace by this term. Okay. Let's see whether I caught all the terms in. Okay. So this partial eta partial y is a multiple. Then I will need to put this in, the theta square, theta on top, theta prime on top, and you notice what happens to this. Okay, so basically I just split this here to get this using a chain rule. Then I will combine these two together. This becomes theta double prime. Theta double prime, and you just have eta square over y square. Okay, so that's the rightmost term taken care of. Rightmost term is taken care of, so you can substitute that in. And what about this term? Okay, this term here is just partial theta partial y. Partial theta partial y is also pretty simple. We see that if we substitute theta in here, you just have eta over y over here. Okay, so let's just substitute all of these in. Okay, substitution back in. Alright, let's substitute this back in. Partial theta partial y will become eta over y, because partial by partial y is actually eta over y. Partial eta partial y is actually just eta over y. Then you have partial by partial eta of theta. So this thing becomes let's see, eta over y, and then you have a theta prime here. The other one becomes okay, y square at the bottom, eta square on top, and theta will become a double prime, because as per what you see over here. All right, good. Okay, so now we most likely we hope we can start cancelling terms out. So let's we may want to try to attempt that. Okay, so let's see, this theta prime and this is also theta prime. We will try to we'll try to just tidy this up, because this looks extremely messy. Okay, so what can we do? Okay, let's start tidying up the left hand side, and hopefully I haven't made careless mistakes, but well, I kind of expect myself to anyhow. Oops, yeah. Tidying up, we will have, okay, so we have f prime to combine with the eta on top. 2 and 2 make 4. 2 times 2, and that will be the coefficient of this theta prime term. Okay, next thing is this part where there are collection of terms, but let's tidy them up as well. Okay. Yeah, let's tidy them up as well. So L will be multiplied in, and eta over y theta prime will be multiplied in as well. And let's take the minus sign out. Okay. So let's take the minus sign out. Okay. Let's bring the L in. Let's bring the L in. And eta over y theta prime, we bring it to the front as well. Now it does look a bit messy still. Yes, it does look very messy. Okay, in that case, let's see whether we can bring theta prime to the back just to see whether it's neater. And we'll bring eta y to the front. Eta and y to the front. Let's go. And I want you to notice something. Okay, if we were to multiply this theta prime in, this term and this term, they have the same coefficient, so to speak. So I'm going to multiply this theta prime in. Let's multiply the theta prime in, and we'll see it looks like this. So what do we have? We have eta f prime theta prime, eta f prime theta prime. So let's, this one we can sort of do a little bit of factorization. Okay, do a little bit of factorization. Okay, so we'll try to combine these two together, though of course both of these have eta over here. So in fact there's eta times eta here is actually eta squared. We may not want that to be the case. Okay, so we might replace one of these etas with what do you call that, a relevant number or something like that. Okay, but regardless, okay, this eta f prime theta prime is going to apply. So let's multiply this in. I don't know, I might have made a careless mistake somewhere just now, but we'll see. We'll try to remedy it on the way. So minus half, blah blah blah, all the way to the Reynolds number there. Okay, I'll just put a plus here, minus here, and the minus will become a plus. There you go. Okay, so I think I can remove the brackets now. Let's remove the brackets. And let's see what we can do about the terms together. Yeah, looks a bit messy, but let's see what eta over y is. Okay, we will try and combine these two terms together. So we factorize out the eta f prime theta out. And we'll bring this in as well. And of course we'll factorize out the same terms. Okay, now let's carry on. Okay, we'll try to deal with these terms here. Okay, so eta over y. Let's just do that first. Eta over y. Okay, eta over y will be whatever we found earlier. Okay, so let's look for eta first. Let's see the for RHS part. Yes, eta over y is here, so it's a half square root of all that thing in there. Let's use it to replace eta over y. Okay, so 2 halves will become 1/4. Where did I have that? Oh, I think I pasted it at the wrong place. Okay, I want to replace the eta over y inside the bracket. Okay, so yeah, 2 halves will still become 1/4, but on this term, not the other term. All right, good. Let's bring this together to 1/4. Okay, and notice here this is actually a square root of the Reynolds number. You can see it's a square root of the Reynolds number over x squared. Yeah, square root of Reynolds number over x. So let's do it. Square root of Reynolds number over x. Square root of Reynolds number. So this will be RE on top. And I can just put it over x squared. So I can bring x out. Okay, I can bring the x out. So I don't really need it in there. Alright, so I'm just dealing with this part. Let's put REX just to be clear. REX. And of course now you'll see the Reynolds number actually cancels out, which is pretty convenient for us. At least that part of the math is right. So the Reynolds numbers cancel out. Square root REX and REX here. Okay, and of course that actually just reduces to x star. X star. And then you can combine both of these into half. You can combine both of these into half. Okay. Yeah, put that. Yeah, I can combine both of these into a minus half here. Minus half. Okay, so at least that term's being tidied up very nicely. Alright. So let's see, what else can we do? Okay, well, I'm gonna stop for now. It looks like we'll have to wait. It's already 24 minutes in, so I'll continue next time. If there are any careless mistakes, I'll let you know, I guess. Okay, but we'll take it as this for now. Okay, bye.